Hi everyone, in today's challenge we are going to solve this problem. The problem name is minimize the maximum difference of pair and the problem number is 2616. Alright guys, so first of all what we are going to do, we are going to clearly understand the problem statement. First of all we will understand the problem statement. After understanding the problem statement then we will move to the logic part. And in the logic part we are going to see how we can solve this problem, what is the logic we are going to use to solve this problem. So after understanding the logic part, then we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java, and JavaScript programming language. Fine, guys. And guys, if you want to have a look on the solution, which I'm going to write in this video for Python, C++, Java, and JavaScript programming language, I will share the link in the description. You can go through that particular link and you can find all the solution, right? Fine. Now let's see what this problem says. So let's understand the problem statement. So guys, problem says you are given a zero indexes integer array nums. So first of all, one thing is clear that we are given one integer array, right? That is first input, right? Fine, and an integer p. So second input is nothing but only integer, right? Fine. Find p pairs of indices of nums such that maximum difference amongst all the pair is minimized. I hope you are getting this. Now what we need to do, we need to, this is nothing but p, right? And this is nothing but nums. So we need to do nothing but we need to find p pairs. We need to find p pairs of these nums indices, right? Such that the maximum difference amongst all the pair is as minimized. So let me just give an example. Let's say we found two pairs, or let's say three pair, one, two, and let's say 3 and 5, and let's say 2 and 10, right? So let's give it a name, 6 and 10, right? So now guys, you can see the difference here in each pair. In this pair, first pair, the difference is 1 only. Here the difference is 2. Here the difference is nothing but we can say 4, right? So we have to find here maximum difference. So maximum difference is nothing but 4 only, right? Fine. And this three pair I have created from my nums array. So I can create a distinct three pair, right? This is the one possibility of creating a three pair. You can create you can have another possibility as well, right? So you have to check all the possibilities and you have to minimize this maximum difference. So let's say another distribution of pair giving a maximum difference in nothing but 3 only, right? And here I'm getting 4, so I have to return 3. I just need to find a minimum. I have to minimize the maximum difference, right, by choosing a best possibility of the pair, right? So this is the simple meaning of this, but don't worry if you're not getting. Let's see the examples and we'll see everything. But first of all, let's cover this problem statement only, right? We haven't covered completely, so let's cover this problem statement. So problem says next, also ensure no indexes appear more than once again amongst the p pair, right? So this is also clear that if we are taking one index in my pair, so I should not take that index in another pair, right? So let's say I have taken two in second, in this is index, right? If second index and third index, so I should not take second and third index in any other pair, right? Fine, that makes sense. Note that for a pair of element at the index I and j, the difference of this pair is nums of I minus nums of j, where x represents the absolute value of x. Now, guys, let's say we have this pair, right? 2, 4. So here the difference is going to be nothing but 2 only, right? They are taking an absolute value. 2 minus 4 minus 2 minus 2 is going to be plus 2 only, right? Or we can say 4, 2 is also 2, right? Fine. Return the minimum maximum difference amongst all pair. We define the maximum of any empty set to be 0. So let me just tell you here, guys. So here they have told us simple thing, the same line which is nothing but here, maximum difference among all the pair is minimized, right? So here also they said we just need to find the minimum, right, out of the maximum difference which we got from the all the possibilities, right? We have to find the minimum and we have to return that particular minimum value, right? Fine. Now let's see the example. Let's try to understand from the example, right? So in the first example we have nums which is nothing but 10, 1, 2, 7, 1 and 3, right? So this is nothing but our nums array. Fine, we go to our nums array. Now what we are going to do, we are going to say p is equal to 2. That is also cool. Means nothing but we have to make a two pair, right? With different indexes, right? No indexes we can say should be repeated in any other pair, right? Fine. Now there could be many possibilities, right? So the first possibilities which we can say 10, 2, 10, 7. There could be many possibilities, right? No 10, 7, 1, 7, right? Fine. So I can get this, but this is going to give a maximum difference nothing but what? This is giving a 8, this is giving a 6, so maximum difference is 8 here, right? But there could be one more possibilities which is nothing but 2, 3, and we can say 10, 7. So this is giving a maximum difference 1, this is giving maximum difference 10, 7 is 3, right? So here we can say difference is nothing but maximum 3. But there could be one more possibilities which we can say 1, 1 and 2, 3. You can see I'm not repeating the indexes. One is repeating twice, so I have taken it twice, right? Let me just do this part. So I have taken it twice, but indexes is different, right? This is at a second index or first index, and this is as a fourth index, right? So 1, 1, 2, 3. 1, 1 is giving a 0, this is giving a 1. So here maximum difference in nothing but we can say 1. So you can see we just took a three possibilities, right? And here I'm getting a maximum difference in nothing. We can say here I'm getting a maximum difference 8, 3, and 1. And out of these, the minimum is 1 only. So we have to return 1, right? And there could be more possibilities, but all these possibilities will not give a more than less than 1, right? They will always give a maximum difference, which will be always greater than 1. So I just took only these three possibilities, right? So we got our answer 1, we have written answer 1. So I hope guys you understood what this problem says. So problem says I am going to give you a nums array and a b value, integer value. You have to just take all the possibilities of pair, and you have to find the maximum difference all out of all those possibilities, and you have to return the minimum, right? Simple. Fine. Now let's see the example second. Here we have this array 4, 2, 1, 2, and p is 1. That means nothing but we only need to create one pair, right? So if you it is the case, they have taken a 2, 2 only, right? 2, 2 pair, and this is going to give answer 0, right? The max difference is 0, and this possibility is the nothing but minimum, right? So you can see we are getting answer 0, right? Because you can't get a less than 0. Why? Because we are taking absolute value. If even you are getting a 2 and 10, it always going to give a plus 8. Why? Minus 8 is also going to convert into absolute, which is going to be 8. So you will never get a value which is less than 0, right? That is sure, right? Fine. So now guys, we have understood the problem statement. Now let's see the logic part. But before that, let me summarize this. Simple thing, we are given one array, second one integer. Array integer tells us that how many pair we need to create, and from the given array, right? Now we need to find the minimum value out of the possible pair, out of all the possibilities which we have created, right? Which include all the pairs, right? So simple thing, we need to find the minimum value, right? Out of the maximum difference from all the possible pair. Now let's see the logic part, and let's see how we can implement this one, right? Not implement, understand this one, right? So let's write a logic. So let's see how we can solve this problem. Simple thing. So for that, we are taking this first example only, and we are trying to see how we can solve this problem, and then we will move to the implementation part. So 10, 1, 2, 7, 1, 3, right? 10, 1, 2, 7, 1, 3, 10, 1, 2, 7, 1, and 3. And p is nothing but we can say what 2. So that means nothing but we have to create a pair, which is nothing but we have to create two pair, right? Fine. So what we can do guys here? Simple thing. We can't do all the possibilities, right? If we are taking all the possibilities, so it's gonna take a long time complexity, right? So if this will gonna map with all these things, then this will gonna map with all these things. So we can say this is gonna take a square time complexity, right? But we should not do, right? So what we can do, we can say simply think guys, can you use something called binary search? Think about this. And I know it's hard to recognize in this problem that whether we should use a binary search or not. Why? Because you are not seeing any order in this, right? They are not in sorted order, they are not having any order, right? But still we can use a binary search here by taking another search space. Think about this. Yes, we can use a binary search here. And by how I'm seeing this part, let me just show you here. Binary search, right? So guys, I know this is not in order, this array, but our answer is in order, right? So let me just show you here. So my answer is nothing but let's say 0, right? And let's give it here 10. Okay, so my answer will never go less than 0, and also never go more than 10, right? Why I'm saying this? Just try to think about in your mind that we have this array, right? And they are asking us to maximum possible difference, right? From all the possibilities you have to find the maximum, we can say minimum, right? Not maximum, you have to find minimize, you have to minimize the maximum possible difference, right? Simple thing. So how you can minimize, right? Not minimize, forget to minimize as well. So if you take any of the pair, if you take any of the pair from this particular we can say array, let's say you're taking 10 and 1, right? I've taken the biggest value here and the smallest value here. So if you do subtract, if you find a difference here, you will get 9. You can see you can get at max 9. This is the maximum for any such case, right? This can be the maximum one for any such case, but we don't need to return, we need to return minimum, but this could be the maximum one, right? So I have given a search space 10, which is also greater than 9, right? So simple thing guys, we know that we will never get answer which is greater than 10, right? Because we will, all the maximum, we can say maximum possible difference will also less than 10, and we have to find out the minimum from them, and we have to return that answer. But we know that answer will never goes more than 10. And how I can see that? Because I am just taking the biggest value from this my num set. Just you have to take a maximum value, and you have to write here at the last search space, right? So we can say 0 is the nothing but at max, or we can say at such in such case we can get a 0 also, right? But we will not get negative. If we are getting negative, we have to convert it into absolute value, we have to make it positive. So minimum we can get these possibilities. At max we can get this particular we can say difference, but right. So I hope this makes sense. So we got our search space. Now we can use the binary search over here. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is our number, right? So what I'm saying, I can use this search space for my binary because this is in order, right? This is in sorted order, right? And why I'm saying that I created this search space, because I know if I am getting answer 5, if I know my I can get up 5 as a because maximum difference. Uh, Let me just write a 5 is nothing but we can say minimum. If I hope it seems 5 is nothing but minimum out of all the possibilities, right? Out of all the possibilities of maximum difference, right? So I'm getting a 5 as a minimum. So I'm sure that 6, 7, 8, 9, and 10 will also be possible to get, right? If I'm getting a 5, that means this is the possible one, right? 6, 7, 8, 9, 10 is also a possible one, right? So just let understand one case, right? Simple thing. You have use a binary search. So this is nothing but your low. This is nothing but your high, right? Now you are going to create find out the mid. So let's find out the mid. 10 0 plus 10 divided by 2 is nothing but we can say 5. So you got a mid nothing but this 5 only, right? Again coincidence. Fine. You got a mid this. Fine. So what I'm going to say, I'm going to say fine. I got a mid. Now I'm going to check whether I am able to get this answer. Whether I am able to get a 5 as a minimum. 5 as a minimum out of all the possibilities. So if I am able to do, let me just write a case now. If yes, and if no. If yes, if I am able to get this 5 is the minimum difference out of all the possible maximum difference, then what I'm going to say, I'm going to say fine, you have to move to the left side. Why left side? Because I'm sure that 6, 7, 8, 9, 10 will always be my answer, right? Because 5 is the, if I'm getting a 5, 6 will always be, 7 will always be, 8 will always, 9 will always, right? But for less than, we may, as we need to find minimum, right? So there could be possibilities that 3 could be the minimum, right? 5 is the minimum, fine, it is cool. But 3 could also be the minimum, right? So we don't know what the left side. We have to move to the left side. If we are getting a 5 as a, if we are able to get 5 as a minimum difference out of all the possible maximum difference, right? Fine. But think about this. If we are not able to get a 5 as a minimum out of all the possible maximum difference, so what we are going to say? We are going to say definitely all this will not be our answer, right? 1, 2, 3, 4 is not going to be our answer. Why? Because we could not able to make 5 as a minimum, right? How we can make 1, 2, 3, 4 difference as a minimum out of all the possible difference, right? So we'll say move to the right side. Simple thing. There could be 6, 7, 8, 9, 10 could be the minimum out of all the possible maximum difference, but definitely 5 and less than 5 will not gonna be your answer, right? It is making sense, right? Simple thing, guys. If you're able to make a 5 as a minimum possible difference out of all the possibilities, then you can say fine. We can get there may be chance that we can get 2, 3, 4 as a minimum, right? Because 5 is the minimum, right? So we are going to store in our answer. We'll say okay, fine, store in our answer this 5, but also check for the left side. Do we are getting any this? Do we are getting any number which is also satisfy our condition, right? If we are getting that number, so we have to store that number in our result. We have to update our answer. But if we are not getting, so we'll return our answer, right? Same thing over here we are doing. So we are saying that if we are not getting this 5 as our minimum answer out of all the maximum possibilities, then what we are going to do? We are going to say fine, don't worry, move to our right side and not storing our answer. You don't need to store it, right? Because this is not our possibilities, right? I hope it makes sense. If yes, so we have to store in our answer. If no, we have don't have to store our answer. If yes, then we have to move to the left side. If no, we have to move to the right side. I hope this making a sense, right? Fine. Now let's see the one more thing. How we can say if this 5 is satisfy the condition or no. So here in this example, let me just show you. In this example, we have this array, right? So we have written this array over here, 10, 1, 2, 7, 1, 3. So we are going to check whether we can get a 5 as a minimum out of all the maximum possibilities from this nums array, where pair is nothing but 2 only, right? So let me just show this as well. So pair is 2, 10, 1, 2, 7, 1, 3, right? This is, let me write again here, 10, 1, 2, 7, 1, 3. So what I'm going to first of all sort it, right? So we can say 1, 1, 2, 3, 7, and 10. Anything else? No. So what I'm going to do, I'm going to say sort it. So we are going to sort it one time only, right? We are not going to sort it again and again. So what I'm going to do, I'm going to say find. So find two pair, first two pair, 1 and 1. You can say this pair. So if we are finding this pair 1, 1, let's see 2, 3, right? So we go to this two pair, right? There is maximum difference is here difference is 0, here difference is nothing but we can say 2, 3 is 1, right? So here maximum difference out of this is nothing but 1 only, right? So we are getting a this difference, right? And if we are able to get this difference, this is nothing but we can say our difference for this. So this is nothing but less than our 5, right? This is less than our 5 or equal to our 5, right? We can say less than or equal to 5. So that means nothing but it is satisfy the condition. Why? This is yes. We can say storing this in our answer because we are able to make our 5 as an answer, which is nothing but you can see guys here we are getting a 1, right? We are getting a 1 which is nothing but less than or equal to 5. I hope it making a sense. This is nothing but less than or equal to 5. So we can say we can get 5 as an answer which is nothing but maximum, we can say minimum, right, out of all the possibilities, minimum, right. 5 is nothing but our answer, right, because there could be less number, you can see, we can get 1 as well. So there could be less, more number which is less than 5 can also satisfy condition, but this is also satisfying, right. So we are going to store in our answer is 5. Now we have to move to the left side, right. But for now you can see guys, we are getting nothing but pair, right. All these pair having a less than 5, this is also 5, this is also 5, right. So just for simple thing, I know it's quite confusing, just in, you can think about like this. We got a 5 mid and we are going to check if we are able to get a pair. All, if we have to get two pair, if we are able to get two pairs, or we can say the two pairs which are having a difference less than 5, just we need to find two pair which are having a difference less than 5. If we are able to find two pair which are having less than difference 5, then we have to return yes, otherwise we have to return false. Simple. So I find a two pair 1 comma 1 and 2 comma 3 which is having a less than 5. Simple thing. There could be one more pair that is nothing but 3 comma 7, we can say not 3 comma 7 comma 10 as well, which is giving answer 3. This also satisfies the condition, because this 3 is also less than 5. So we have to just find at least there should be two pair present which having a difference less than 5, which are having a difference less than 5, right. So fine, if it is so, yes, so we have to move to the left side. Now we are moving left side. Why? Because we know that guys, there could be a number, right, there could be 2, 3, any number which is also satisfying this condition, right. You can see here, if you see 0 and 1, so here you will focus 2 is also satisfying the condition, 2 is also less than 0, 1, 2 is also less than 1, no sorry, 2 is also, we can say 0 is also less than 2, 1 is also less than 2, right. So 2 is also satisfying the condition. So we can say after that we are going to say fine, update in answer 2, fine, then move to the left side. Maybe 0 or 1 also satisfy the condition. So if you see, we find two pair, again we are going to find this two pair, and we are going to say 0. So we are checking for 1, right. So you can say 0 is not satisfying the condition. For 0, if you are saying that 0, it's not going to satisfy the condition, because here 0 is not less than 1, right. But for 1, it is going to satisfy the condition. 1 is also, we can say, greater than 0, and 1 is also greater than or equal to 1, right. So that means that we can say for 0 our answer is not going to update, but for 1 our answer is going to update, right. So we are going to say update answer to 1, and we will see if we have reached to this one. So we have reached our, we can say we have completed our search space, there is no more search space left, so we are going to return this answer. And it's quite hard, right, but don't worry about this simple thing. In just mind, we are using a binary search, we are finding a mid, and if we are getting, if we are satisfied the condition, moving to the left side. If we are not satisfied the condition, moving to the right side. But whenever we are moving to the left side, we are storing this mid in our answer, because this is our one possible answer, but it is not a minimum one. We are guaranteed that we are not saying this is a minimum one, but this is the answer, right. So we have stored in our answer, and we are moving to the left side. If we are again finding something on the left side, we have to update our answer, because now we have got a minimum, right. But fine, it makes sense, right. Now let's move to the implementation. You will get all your doubt clear in the implementation, right, because I know it's hard to understand from the logic. It's also not such a great example. So let's move to the implement example, and let's see how we, let's move to the implementation part, and let's see how we can implement this, right. So guys, I'm first of all with the Python. So what I'm going to say, I'm going to say fine, first of all get your search space. So search space, before that we have to sort it. So we can say nums dot sort. Fine, once we sorted, so what we are going to do, we are going to find. So we can simply say, let's take a search space. Low is nothing but 0, high is nothing but maximum value from nums, right, maximum of nums. Or we can say, if it is sorted, so last value is always going to be maximum. Fine, now we go to search space as well. So what we are going to do, we are going to say use a binary search while low is less than high. All right, so we are going to say find a mid, low plus high divided by 1, not 1, 2, right. So this is bitwise operator. Fine, now we are going to check if possible with this mid. If possible with this mid, if we can solve with this mid, we can get our answer, right. If we are able to get this minimum answer, right, if we are able to get this mid out of this old pair, so what we are going to say, we are going to find store in our result, store in this mid, store this in our answer, this mid, and after that we can say move to the left side. So is, high is going to be mid minus 1. Else we can say if it is not possible, right, with this mid, we are not able to get this mid as a difference, right, which is the maximum difference out of, we can say all the p pairs, right. So we can say fine, what we are going to do, we are going to say fine, move to the right side. 2 is going to be mid plus 1, and don't store in our answer, right. Fine, fine, and answer is by default is going to have what, and we can say this is going to give an error, right. In Python we can't do this, we can use a tuple in, right. So we can do one thing as well, right. So we can say like simply low comma high, right, which is nothing but 0 comma nums. Fine, and also we can say our answer, right. So we can say our answer is going to be nothing but minus 1 USD. Fine, after that we can simply say after this value we can simply return answer. Now guys, we have used a binary search, we have done completely binary search, right, but we have used one function possible which tells us that whether this is possible or not, right. So let's define this function, let's see how we can do this. So define a function possible. which is going to take a mid. Now what we are going to do, we are going to find for I in range of length of nums and starting from one index, not zero. Fine, because we need at least two pair, right? We need at least two element to make a pair, right? Fine. So what we are going to do, we are going to say fine. If nums of I, let's take absolute value. If nums of I minus nums of I minus one, if this absolute value is less than, we can say our mid or equal to mid, we can say count plus equal to one. Fine. And here we can go to this one, and we can say initially count was zero, right? And also we cannot use I for loop here. Let's use a while loop, right? Why I'm saying while loop? Let me just show you here. Count is 0 and I is equal to 1, right? Fine. While loop will say while I is less than length of nums. So this while loop we are using because we have to update I in between of this, right? So I'm going to say here I should be update if we are getting a pair, right? And we can say if it is not the case, don't worry, don't increment the count, don't increment the I as well. And I is plus equal to 1 for regular while loop, right? After that we have to check, do count tell us that how many pair we got which have a difference less than or equal to mid. So it is greater than or equal to p. If it is so, return true, otherwise return false. If it is less than p, that means we could not find we can say our p pairs which have a difference less than or equal to 5 or 5 not 5 mid, right? Now let's see whether this we can find or no. So I hope guys it should work. Let's see. You can see both the task is passed, so let's try to submit this code. And I hope it will also want to submit. Simple thing guys, just we are checking whether it's possible with this mid or not. So if with this, then return true, move to the left side, otherwise move to the right side. Let's move to the C++ programming language, and here we are going to find, okay, we are going to say low, not low. First of all, we have to sort it, right? So we can say sort nums. So we can use a simple sort, right? Nums dot begin, nums dot end. After sorting, we are going to say find int low is going to be nothing but 0, I is going to be nothing but we can say nums dot back, right? After that, we are going to use a while loop while low is less than equal to high. So we are going to say find, we are going to find a mid. So mid is going to be nothing but low plus high divided by 2, and we can use it this. After that, we are going to say if our mid, if possible with this mid, if it is yes, then what you are going to do, you are going to say we can say store in our answer. Now so we can say move to the left side. So high is going to be nothing but mid minus 1. Fine. And if it is not the case, then you have to move to the right side. So low is going to be mid plus 1, and you don't need to store in our answer because this is not a right answer, right? And then you have to return your answer, but answer we haven't defined, so we have to define answer as well. Int answer is nothing but equal to minus 1. Fine. So now what we are going to do, we are going to find this makes sense. So we are going to define one function possible. So let's say this is going to give a bool value possible, and this is going to take a not only mid, right? As this is out function, so we have to pass in nums as well. We have to pass for a p as well, right? Fine. So first of all, we are taking a mid, so we let's say mid. Then we are taking a vector of int nums. Then we are taking a p. So fine. Once we got this, we are going to check. So what we are going to say, we are going to find. So we can say you initially say count 0. We don't have any pair right now which have a less than difference less than equal to mid, and also I is equal to 1. Right? While our I is less than nums dot size. So what we are going to do, we are going to find first of all find if nums of I minus nums of I minus 1 and absolute value of this is less than what I have done. If it is less than equal to our mid, right? So that means this is one possible pair. So we have say count plus plus and I plus plus. Otherwise, we are not going to increment a count as well as I, right? And I plus plus, this I is for nothing but regular I update, right? Fine. After that, we can simply say after this value return if your count is greater than equal to p. That means you got at least p pair or more than p pair which having a difference less than equal to mid. If it is the case, then you have to say return true, otherwise return false. Now let's see whether it's working fine or not. And I hope guys it should work, right? Let's see. Okay, it's taking a time. Okay, so you can see guys it has accepted. Now let's try to submit this code. And let's see first of all. You can see guys it successfully got accepted. Now let's move to this Java programming language and quickly here. First of all sort it. So we can say array.sort. That's simple. Array.sort, and we can pass our nums. Right. After sorting, we are going to say int low 0, not low, and high we are going to find. High is going to be your nums of nums dot length minus 1, which is going to be nothing but we can say a last value. Okay, and after that once we can say answer which is nothing but equal to minus 1 initially. Fine. While low Let me write a while low is less than equal to high, right? So what we are going to do here, if low is less than equal to high, then we are going to keep continuing by binary search. So we are going to find a mid. Mid is going to be nothing but low plus high divided by 2. After that we can find check whether it's possible with this mid or not. This is possible with this mid. Then what we are going to do, we are going to find, put in our answer, this mid, and move to the right side, left side. High is going to be nothing but mid minus 1. But if it is also not the case, so we are going to say fine, move to the right side now and don't store in our answer. So for that, low is equal to mid plus 1. And then you have to return your answer. But now let's define this function, possible function. So we can say boolean, return type is going to be true or false. The name is going to be nothing but we can say possible. And it's going to take a first of all int array, int nums. And then int, we can say p, then int mid, right? And we haven't passed this nums and p here, so let's pass this nums and p, right? Fine. So after that, what we are going to do, we are going to find this makes sense. Now we are going to say initially count is 0 and p is, we can say I is nothing but also 1. So let's use a while I is less than equal to, not equal to, only less than nums dot length. If it is the case, keep doing. So we are going to say find if our we are finding if nums of 5 minus nums of 5 plus 1. If it is the case, then what you are going to see, you are going to say fine. You have to increment your count, you have to increment your I, and then you can say ask to increment your I. Right. After that, we can say return simply directly. Your count should be greater than equal to p, right? You should get at least p pair or more than p pair which are having a difference less than equal to mid, right? But here we have seen count of num minus 1 less than p, right? So this is nothing but simple this, right? But this could be in negative, so we have to take absolute. So we can say math root absolute, right? Math root absolute, and we can simply say like this, right? Now let's see whether this working fine or not. And I hope guys it should work, right? Let's see. We haven't put a semicolon here, okay? And let's see now. And you got an error nums of I or not I plus 1. I don't know why I'm using I plus 1, I minus 1, right? Otherwise we have to use I less than nums dot length minus 1, right? Fine. You can see guys all the rest is passed. Let's try to submit this code, and I believe it should also get submitted. Let's see. And you can see guys it successfully got submitted. Now let's move to the next programming language, which in mathematics is JavaScript, and this is the last programming language. So first of all we are going to sort this nums, num dot sort a comma b, a minus b. We can say fine. Now let's take a low which is nothing but 0, high less than nums dot length. We can say nums of nums dot length minus 1, the last element, and answer is going to be nothing but minus 1. Fine, we got these three value. Now we are going to use a binary search. While low is less than equal to our high, so we can find a mid. Low plus high divided by 2. Once you find a mid as well, then what you are going to do? You're going to say fine. Now we check if it's possible with this mid or not. If it is possible, so what you're going to say? You're going to say fine. We got a possible mid, so we are going to put in our answer and move to the left side. So we can say high should be low minus, we can say mid minus 1. But if it is not the case, if it is not possible, so we can say move to the right side. So low is going to be nothing but mid plus 1. And we are not going to store in our answer as well this mid. At the end, we can simply return answer, right? Not return, so we have to use return, right? Fine. So now one thing which is left, nothing but we have to make a possible function. So let's make a nested function only, most possible, which will help us to avoid passing nums and p. Most possible is going to take only mid value now. This thing that count is nothing but initial 0 and I initial 1. So while I less than what we can say I less than our nums dot length. So we have to find it is cool. Then what we can say 4. Not 4 we can say if our absolute value math root absolute nums of I minus nums of I minus 1 is less than equal to mid. That means this is one possibility. So we can take this pair. So if we are taking this pair, we are going to say count plus plus I plus plus, and after that I plus plus. I hope guys you know why we are using I plus plus inside this and why we are using outside. Outside is nothing but for this whole loop, while loop, but inside this is nothing but we are taking a pair. So we are taking pair, we are taking a two value, right? So whenever we are satisfying this condition, we have to do two time I plus plus, one time this, one time this. And if we are not taking, we have to do just only one time I plus plus, right? At that we can say return count. We can say our count number of pairs should be greater than or equal to p, right? Let me write this. Let's see whether this working fine or not. And I hope guys it should work. Let's see. Right. So you can see both tasks is passed. So let's try to submit this code and let's see whether it's getting submitted or not. And you can see guys it's successfully got submitted, right? So we have done the implementation with Python, C++, Java, and JavaScript programming language. Fine guys. And guys, if you have any kind of doubt, in logic part, implementation part, problem understanding part, you can write in the comment section, right? I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.